Although we saw a very simplified approach for understanding the backpropagation, but in reality backpropagation is an algorithm with a lot of details and it could be tricky to implement. So at times it seems that we are going in the right direction and cost function is decreasing. But there may be some bug in the implementation and we might end up with high level of error. Hence we introduce the idea of gradient checking, which ensures that we are going in the right direction. So if you see the graph here, we know that derivative is nothing but the slope of the curve at a particular point. So if we want to calculate the slope of the curve at a particular point, we will calculate its derivative. Now to calculate the derivative, we draw a tangent on the curve and then simply calculate the slope of that line. So as shown here, slope of line 1 is nothing but the derivative of j theta at point theta. Now slope of line 1 can be approximated by slope of line 2, which is adjoining 2 points on the curve as shown here. So why are we doing this? Because it is easy to find the slope of line 2 compared to slope of line 1. And the slope of line 2 can be considered an approximation of slope of line 1. So it is better to find the slope of line 2 because it is easier. Now the 2 points on line 2 are nothing but theta plus minus epsilon. And epsilon is generally considered as 10 raised to the power minus 4. Hence we can write the derivative as j theta plus epsilon minus j theta minus epsilon divided by 2 epsilon. Similarly, if there are more than one variables, we can extend the same concept and we will use partial derivative there. Recall, partial derivatives are also derivatives but taken by making other variables as constant. So this is known as numerical approximation, and this is how gradient checking is done. Now the idea of gradient checking is to check if the derivative terms computed by backpropagation are approximately same as the one computed using numerical approximation. However, numerical approximation is computationally slow. So what we do? We compute derivatives for few iterations. Let's say maybe up to 5th iteration. So up to 5th iteration, we use both numerical approximation and backpropagation. After that, we check if partial derivatives at the initial weights are approximately same from both the methods. Then we turn off the gradient checking and execute only the backpropagation. Because now we know that we are moving in the right direction. So that was the whole purpose of gradient checking. It guides us in calculating the optimized weights.